ahead.
Okay, so it says solve for each triangle, and A equals 79 degrees, B equals 33 degrees, and A equals, or lowercase a, equals 7.
Okay. Notice they've given us two angles, which means we can figure out all three angles.
Yeah.
We have one side, so what law are we going to use?
We're gonna use law of sine, right?
Correct. And is this a potential ambiguous case?
I don't know. What is that? What does that mean?
Oh, you haven't studied the ambiguous case for the law of sines?
I don't remember going over it.
Okay.
Maybe.
Well, there are certain triangles where I can give you three pieces of information, and if it's angle side side, it could be two different triangles.
Oh, yep. Yeah, we've done that.
Okay, and let me just draw a quick picture of what I'm talking about here. Let's say that's 30 degrees. That side is 10. That side is 8. So it's angle side side. But there's actually two triangles that fit that exact same. That's 10. That's 8. So there are certain triangles, if they're angle side side, where you might have two solutions. It's called the ambiguous case because you don't know which one they're really talking about.
Okay.
And the reason we know this problem you gave me is not the ambiguous case is because we have two angles, which means we have three angles. Whereas in this situation over here, that angle is not the same as that angle, and that angle is not the same as that angle.
Well, and also for that one, don't you have to use the law of cosine?
No, for the ambiguous case of the law of sines, you still use the law of sines.
Oh, okay.
Whenever you have an angle and its opposite side, you're strictly on law of sines. No more law of cosines. The moment you get that, remember, law of cosines is where you have side, 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 no angles, or side, angle, side. In other words, you know that one, you know that one, you know that angle. Well, I do not have an angle and an opposite side in either of those pictures.
Oh, I see.
That's
okay.
the only two times you ever begin the problem with the law of cosine.
Okay.
In other words, every other situation where they give you three pieces of information, they're giving you at least one angle and its opposite side. That automatically says law of sines.
Okay.
So, what equation can I use? Here, let's draw an approximate triangle here. Use this one.
Well, just based off of how I drew the triangle, I did the sine 112 over 7, because that's the remaining angle, right?
No.
112 degrees.
Angles have to total 180. Did I write this down right? Is it 79 and 33?
Yeah, I might have just calculated. Oh god, I might have just done that wrong.
Because that
oh my,
I'm so dumb.
No, it's not 112.
Huh?
It's not 112. I did it wrong.
Where you got the 112 was just adding those two.
Yeah, I added them. I didn't.
It's 68.
Yeah.
Okay.
So then that would be.
So there's our triangle, and that we actually know four pieces of information. So
yeah.
What? Give me an equation to write.
Sine angle A over.
Sine of 79 degrees.
Okay, sine of 79 degrees over 7 equals sine of 68 over, you want to call that side B?
No, we're going to call that side little c. In other words, little b has to be opposite angle b.
Okay, well,
So that was
oh, yep,
capital
true.
C was the 68, which means the little c has to go under it. And now you just have
Okay,
to solve that. You have any problems solving that?
yeah.
Just cross multiply.
Just cross multiply?
Yeah, because the variable, in other words, there's only one variable there. It's that one right there. Everything else
Right.
is a number.
Okay.
So after I cross multiply and divide, I get C equals 7 sine 68 divided by sine 79. So there's your, you can convert that to a decimal, or you could give it as that answer. That's actually the most precise answer. Because sine of 68 gives you an irrational number that you have to round off.
Okay.
All right, what else you got?
Okay. I'm actually going to take some pictures and email it to you really
Okay,
fast because I feel like that'd be easier because some of these are word problems.
that's fine, and actually I prefer that because I have an eraser when I'm writing on documents that you email me. Whereas in
Oh,
this program, I don't have an eraser.
here, well then I'll just I'll take a picture of this whole thing and we can go over it.
Okay, just hold your,
There's some writing already on it, but
that's fine, no problem. Just make sure that keep steady so we get a clear photo.
hmm yeah, I think they're all clear. Okay.
It's David Cowan, 1949 at Gmail.
Okay.
Just holler when it says sent.
So wait, are there any capitals? Oh, I think I got it actually. I already had it.
Yeah, you
Uh,
should have it. You've sent me stuff before. So once you send me something one time, it should stay in your default. So all you have to do is type DA and it should come up.
right, and I'm gonna send you 4 different pictures.
Don't send them all at once. Send the first one first and then the other 3. Because when you send 4 of them at the same time, it'll take 4 minutes to get in.
Okay.
One, it'll take 40 seconds.
Right.
Not even that. It's not linear. It seems to be exponential. The more stuff you attach,
The longer it takes to
well,
send.
it's not just the longer it takes. That would be even a linear relationship, but it's like exponential.
Okay, so I just sent you 4 emails. They should be getting to you any minute.
Okay. Tell me when the first one says sent.
I think they've all actually sent.
Yep. Looks like I got 5 here.
Oh.
I'll start with the first one. This the one you want to start with?
Yeah, take a look at that. Oh, is that sideways?
It's okay. I can rotate it.
Oh, okay, good.
But there only appears to be one question on it,
Yeah.
which is fine. I mean, I don't have any problem with that.
Yeah, I don't know. I just can't see what that says. So I
I
don't know. I might have sent you something wrong or
won't be able
something.
to see it until it opens up. Wow.
Mhm.
Why is that having such difficulty? Now I'm beginning to think it's my computer, not Comcast.
Oh, so that's okay.
That's number 8.
Mm-hmm. Oh, I sent you 2 number 8s accidentally, I think.
Okay. This one you want to do?
Yeah, we can do that one. Start off with that one. Okay.
All right. Let's do the easier one first.
Okay.
Which one is that?
I'm gonna say the B.
Yeah, without a doubt. In other words, these are pretty easy. What you do basically is solve each one for t, and then you eliminated the parameter, right?
Okay.
In other words, this one over here, you get x minus 4 equals t, and this one over here, you get y plus 8 divided by minus 5 equals t. Okay? Well,
Okay. Here.
the same t. So this is equal to that. So you get x minus 4 equals y plus 8 over minus 5. And no more t.
Okay. Sorry. Hold on. I'm writing this down. I'm gonna try and work it for a sec.
Any of these parametric equations that are in x, y, and t, you pretty much can always solve them. You can eliminate the parameter by solving each one of them for t. Then the parameter's gone.
Okay.
Now, the one on the left, A, a little tougher.
So that's it.
Yeah, that's the answer. It didn't, it didn't specify what kind of form it wanted it in. Now, that part there, it didn't say graph these, right? It just eliminate the parameter.
Yeah. Just eliminate the parameter for each. That's it.
I'm not sure why they give you this domain for t, but if we were going to graph this function, it would only go from 1, which is minus 3 for t, to whatever the y value is, or up to 5. So actually, x would only go from 1 to 9. So if we were to graph it, it wouldn't be a full straight line. X would only go from 1 to 9. So wherever that line goes, it's only going to go between those 2 points. So that's, if they'd asked you to graph it, then that domain restriction for t is important. But they don't ask us to graph it. So now let's see, 8. I got to remember how to do this.
Hold on.
There's a trick to do these. I just got to remember. Now I remember what it is. This is a little different because I can't solve for t. I mean, I could in terms of inverse trig functions, but that's not what you want to do. Okay? However, I can solve for sine of t. In other words, sine of t equals x divided by 3, and cosine of t equals y divided by 4. Now, that doesn't look like it helps much, but it does. We are going to square both sides. Okay?
Okay.
Sine squared of t, x squared over 3 squared. This becomes cosine squared of t, y squared over 4 squared. And now I'm always allowed to add equations. So here's what I get. Sine squared of t plus cosine squared of t equals x squared over 9 plus y squared over 16. Well, what's your trig identity for sine squared plus cosine squared?
That's 1.
Correct. So I'm going to replace that whole thing with 1. Now we're looking at the equation of an ellipse. No t anymore, notice.
Mm-hmm.
So we eliminated the t. And again, I'm not sure what reason they're giving you for that. Maybe they want a new domain for x and y, but it's possible. I don't know. Do you have answers on these?
Yeah, that's what I'm actually trying to find right now.
You can find the answer. It'll help me understand why they gave you this.
Yeah.
They're giving you that because they want you to give the equivalent domain for x and y. In other words, if t's domain is 0 to pi, then x is going to go from 0 to 1, back to 0. Well, times 3. So x's domain would be 0 to 3. I just would like to see their answer to see whether or not they add a domain to this final answer. In other words, what I've circled there is definitely the answer for number 8A, but I'm curious as to whether they want a domain given. Not spend too much time looking for it, though.
Yeah, sorry, I feel like it's right. It's gonna be right here somewhere.
You want me to go on? Since we got 4 documents here to look at?
Oh wait, no, I think yeah, I think I am almost there actually.
Okay.
But yeah, you can go on.
Well, if you're real close to seeing the answer, I would be curious as to what they've put.
Yeah, I actually got it. So yeah, that's all I put is x squared over 9 plus y squared over 16 equals 1.
Okay. And that's just that's the perfect equation of an ellipse.
Mm-hmm. And for 8B though, that first one that we did, he said the answer was y equals negative 5x plus 12.
That's going to be the same thing. Here, let's go through the math again. T is equal to x minus 4.
Mm-hmm.
Over here, t is equal, got to move the 8 over, so that's y plus 8. I got to divide both sides by minus 5. Now I'm going to set that equal to that. What did he say the answer was?
Negative 5x plus 12.
Whole equation. What did he say the whole equation was?
The y equals negative 5x plus 12.
He's solving for that. Okay? So here I'm going to solve for that, and I'll end up with the same thing. Okay, here's what I get. All right. Okay, so now I'm going to multiply both sides by minus 5. And now I got y plus 8 equals minus 5x plus 20. Going to subtract 8 from both sides. Minus 5x plus 12. Okay?
Okay.
So, there's nothing inherently more superior about that answer than that answer. He didn't give any instructions. He didn't say put it into y equal mx plus b format. He just said solve it. He just said eliminate the parameter. So this should have been perfectly fine. I don't think you would have lost points. He would be really hard pressed to take points off if you give him this upper left hand answer.
Okay.
All right.
Mm-hmm.
All right. So the key thing was there were no domain restrictions on it.
Mm-hmm.
I did that. Okay. Sometimes I close out my inbox.
So I know I sent you, I think that's the same question that we just went over.
Okay. Shall we start from the other end? From the top?
Yeah. Mm-hmm.
Because it looks like we're starting from, it's definitely different. So I don't know if it matters the order that we're going to go in or not.
Yeah. And just don't mind the what's already on there too.
Okay.
I just
get all kinds of stuff like that. This is actually the more common thing I get sent to me is where somebody has done part of it,
Yeah.
Okay, this looks a little clipped at the top. Here, I wonder if I can get.
It says find the area. I can read the.
No, I see it now.
What it's.
I actually expanding it brought that into view. So.
Okay.
When you have three sides of a triangle, and it is not a right triangle, there's a formula for the area called Eros Formula or Heron's Formula, one or the other.
Okay.
Seen it both ways, with the n and without the n.
Mm-hmm.
And what it means is, whoops, hold on. See if I can remember it. I use it never. But I believe it's this. Semi-perimeter times semi-perimeter minus side 1 plus, I'm going to have to look it up. Hold on one second.
Yeah, I got it.
You got it? What is it?
Here, I'll get S equals A plus B plus C all over 2. And then the area is A equals the square root of S times S.
Okay, S is the semi-perimeter. In other words, half the perimeter. That perimeter is 14, so S is going to be 7. Okay. What's the rest of this inside the square root?
So it says the square root is square root of S times S minus A times
S minus A. Oh, S minus side A. Okay.
Yeah, side. No,
really, we could call that side 1. And then it's plus.
And then multiplication, like parentheses, S minus side 2.
Okay, and then S times S minus side 3.
Yeah.
That's it, exactly?
Yep, that's what it says.
Where S is the semi-perimeter. Okay, let's see how we should be able to figure out if this makes much sense. So it's 7 times 7 minus 3, which is 4, times 7 minus 5, which is 2, times 7 minus 6, which is 1. So that is the square root of 56.
Which is what?
Well, let's see. That doesn't. Yeah, that does break down a little bit. Yeah, it has to because it's 8. 8 has a factor of 4. So I can. That's 4 times 16. Oops, hold on. 4 times 14. So that is 2 root 14. That's the answer.
2 root 14?
Yeah, now the question is that, in other words, if I wasn't quite sure of my formula, if you're looking at that formula, then that's the answer, for sure. But let's say I wasn't totally sure of it, and I want to approximate what the area of this triangle were.
Mm-hmm.
Well, we know the area of a triangle is half times the height times the base. So that's going to be real close to 5 times 3, which is 15. Half of that, about 7. That's
Yeah.
the ballpark area for a right triangle with those kind of dimensions. And this is
Well,
close to 7. That's close to 7. That's 7 and change, root 56. So,
yeah.
yeah, so that's good confirmation.
Mhm.
Just to know that it fits the ballpark.
And then I just checked, and basically all he did extra was on a calculator he just rooted 56.
And gave you a decimal answer?
Yeah, it was 7.483.
Yuck. Really?
Yeah.
You've been beyond decimals for a year, haven't you?
Hmm?
I mean, I
Guess
thought
not.
all your answers were in terms of square roots and radical signs and stuff like that. Maybe not. I might be
Maybe not.
remembering differently. It's pretty rare to still be converting to decimals. In other words, when you can give an exact answer, which we could.
Mm-hmm.
2 root 14 is the proper area. That's the exact answer.
Okay.
Now, maybe there's instructions at the top of this that I can't read. No, it just says find the area of each triangle. It doesn't say round it to 2 decimal places or anything. That's another reason
No,
that if he's rounding at the decimal places, he should give you instructions on how many places to round it to.
you know what? I agree.
Yeah, for
I
sure.
feel like if they don't tell us that stuff on the test and we don't do it how they want, then
No, for
that should
sure.
not count.
The answer is this. He's not going to take points off for that.
Yeah, hopefully.
It might not be the same as the answer he has, but he won't take points off. Not unless he specifically said, maybe at the top of the test, he may have said round everything to the hundredths place or something.
Fair.
I'm just not seeing those instructions, but
Yeah.
I don't know. So,
Well,
yeah, let's
can
go
we do
on. That's kind of a trivial point,
right?
not particularly important. Number B. There is another area formula for a
Mm-hmm.
triangle when it is side, angle, side. In other words, that's what we have here. There's the 50-degree angle. And
Mm-hmm.
since that's C, these have to be A and B. So this has to be 6 and this is 10. Because they didn't give us little c, which is that right there.
Mm-hmm.
Okay. So the areas of these triangles are, I believe, a 1/2. Let me see if I can remember this. I think it is, let's see, it's 1/2 A times B times the cosine of C. In this case, 50. So that's the general formula. You got that formula in front of you also?
What's it called?
It's going to be in the same section as Heron's formula. Maybe
Uh,
earlier, it's just the area of a formula or of a triangle.
I'll try and
The area
find
of
it.
a non-right triangle. See, the
Uh,
advantage of having this formula is you don't need to find the base or the height.
so I'm looking for an angle side angle, right?
No, yeah, just you don't need to look it up. I'm sure that this is correct, and I'll show you how afterwards. How I know
Mm-hmm.
this is correct. Okay, So the area is going to be 1/2 times 6 times 10 times the cosine of 50 degrees. Now, it does seem like when you have trig functions, they do tend to turn it into decimals more often. Certainly more often than when you have radical signs. And when you have radical signs, it's pretty rare to turn it into a decimal anymore. But when you have trig functions, they're more inclined to give you a decimal for cosine of 50 degrees. So I can understand why that would be a little different. The exact answer here is this. That's the
30 cosine.
exact answer. Because cosine of 50 degrees is an irrational number. If you turn it into a decimal, you got to round it off. So regardless. But here's how I remember that this is the right formula. If you're dealing with a right triangle, and let me just erase this one right here.
Wait, hold on before you go any further. I think it's, I don't know. I according to the answer sheet, I think it's sine instead of cosine.
You're right. Absolutely right. I just remembered you're right. They're all sine. Yeah. And depending on which sides, in other words, you can also have the area equals 1/2 of B times C times sine of A. And the third one is 1/2 times A times C times the sine of B. In other words, you get all three letters, and the only angle you have is the one you take the sine of.
Mm-hmm.
Now, going back to how I was going to prove that I was right and I would have proved I was wrong, I would have figured out that it was sine, because if you take a right angle, well, and then we're going to apply that, right? Well, 1/2 of B times C is clearly the area, and if this is angle A, 90 degrees, the sine of 90 degrees is 1. So when you have a right triangle, its area equals 1/2 BC. Now, had I tried to prove I was right using cosine, well, the cosine of 90 degrees is 0. So I would have immediately known that cosine can't be right.
Mm-hmm.
So I would have found my mistake in using this formula on a right triangle. That will verify that you've got the correct formula.
Okay.
Okay? Yeah, it's odd. Those every student gives me 1 day a year of these, and that's it. That's the only time I see it.
Yeah,
And not
I feel
every
like,
student. A lot of students don't even ever give me Eros Formula, and most of them generally give me this one. That's why I could remember most of it.
okay.
All right. So what next? Number 4.
Yep.
Okay. These problems about trees and angles, these are just triangle problems.
Yeah. So that's angle, side angle.
Well, let's draw their picture. Two observers are 400 feet apart on opposite sides of a tree. There's the tree. There's one observer. There's the other observer. They're 400 feet apart. The angle of elevation from the observers to the top of the trees are 15 and 20 degrees respectively. That's 15. That's 20.
Okay.
Find the height of the tree. Well, we have 3 angles and 1 side.
So that's law of sine.
That's 35, so that's 145. So we have 3 angles and 1 side, so we're not going to be able to use any of those type equations. We're not going to be able to use Eros formula because we need 3 sides for that. Let me think a moment. Okay, now I know how to do it. What's the number one thing we're looking at the way I've labeled it? That we have.
Sorry, what?
What is the one thing you see when you look at this picture? What you should see is that you have an angle opposite a known side. Okay? That means we can use the law of sines to solve this triangle. Once I've solved the triangle, I can figure out the area. Once I've figured out the area, I'm going to be able to figure out the height of the tree because I know the height of the tree is the height of the triangle. Okay? So, let's do it.
Oh, I think I know. Okay, I get how you're going to do it.
The sine. Okay, you lay it out for me.
Okay, so let's do, so it's going to be sine 145 over 400, right?
In other words, that's the only relationship we have where we have an angle and its opposite side.
Okay, and then it's going to be sine 20 degrees over, let's say B.
Okay, we'll call that B.
Okay, and then we can cross multiply, I guess, right?
Right, so B is going to equal 400 sine of 20 divided by sine of 145. Go ahead and give me a number. Let's put a number on that. That's what I say. With trig functions, you are much more likely to convert to decimals. I'm not sure why, to be honest. If we're going to leave square root of 2 as square root of 2, then we should leave sine of 20 as sine of 20. But
yeah,
they don't. They tend to put numbers on them.
Well, here, I'll just simplify this real fast. Hold on.
Okay.
400 sine.
Give me a number for side B.
Hold on. Okay, so give me a sec.
Actually, there's going to be a shortcut. As soon as we get this number, we're just one step away from being done. You should be able to do that in one step on your calculator. You type
I got
400
230.
sine of 20 divided by sine of 145.
Yeah, I know. The reason why it was taking me so long is because I was writing it out too.
Okay.
So I got B equals 238.757.
Okay.
So then that's going to be side B.
Now, notice, now we have a shortcut. We don't have to solve for this other side.
No, yeah, that's what I was thinking, because we can just
cut the flow. Looking at this triangle, the one on the left.
Exactly.
90 degrees. We know that's 15. We know that's 238. That's the height of the tree, so give me an equation that allows me to solve for h.
We'll also, hold on.
In other words, because we're now looking at a right triangle, we can just go back to our definitions of trig functions. What trig function relates h to 238, which are the only two sides we...
Opposite, is it TOA? Tangent?
No.
Wait. No, that's a sine?
Sine of 15 degrees equals the opposite side over the hypotenuse.
Yes.
So h is equal to the sine of 15 degrees times that hypotenuse. And that's the height of the tree. So we really didn't need to solve for the third side of that triangle.
Nope.
Might have if they'd... No. Once we solve for the height of the tree, I can even figure out the area of the whole triangle. But there really is... there's no triangle involved in real life. There's just a tree. So, and they're never going to ask for...
Right.
They're not going to ask for the area here. Tell me when I can erase, and we'll go to the next one.
Well,
I'm not sure how much you're writing. In other words, we're down to this step right here. So h is equal to sine of 15 times 238.75.
Yeah, we can go down to 5 now.
Okay.
I was just looking at it because on my calculator I got like point like 0.
Yeah, that doesn't sound right.
6 off. 0.06 off.
I don't think
of the what it says on the thing.
You have the answer in front of you?
Yeah, I have the answers in front of me.
You came up with something that's not the answer?
Yeah, it's like something really close, but it's not.
Sounds like a round off error. In other words, you rounded this off right here. Or I did.
Yeah.
One of us did. Okay.
No.
So since I rounded that off early, well, now I'm going to round it off again. So it's probably when you do these problems and you don't want round off errors, the best thing to do is to take the first answer out to maybe 4 places. And use that number.
Yeah.
To solve for h, and now round it off. Always you want to round off at the end of the problem, never midstream. Midstream round-offs frequently result in accumulating round-off error.
Actually, now that I look at it, he might have done something wrong. Wait, hold on, let me see.
Well, I didn't do any of these on my calculator, so I didn't check any of these calculations here to make sure that that is side B.
Yeah.
Oh, no, that's right. Yeah, no, I was just looking at this to make sure we had done that correct.
No, I did something wrong. I rounded off something, I think, different. But yeah. Anyways.
Let's go. Those things aren't that important. All right. So let me scroll down a little bit here and take another picture, and let's look at 5. The only thing truly hard about the law of sines and the law of cosines is that ambiguous case. Everything else is relatively straightforward, and it's just laying out an equation and solving it. Here we get a question. Determine the number of triangles formed. What that means is, do we have 2 triangles or 1 triangle? And I'm going to show you how we figure it out. Exactly, the best way to do it. There are multiple ways to do it, but this is really the best way. I'm convinced.
Okay.
I read this in one of my PreCalc books, and I've loved it ever since. this method. C is 25, so we'll make that 25. We'll call that C, and we'll call that A. Okay? So let's use the law of sines to solve this.
Okay.
First thing, solve for angle C, because if it's going to be an ambiguous one, that's the first one you want to solve for, is always this third angle here. And you'll see why after I do it.
So it's going to be sine 20 or sine 38 over 21 equals sine x
C
over sine c over 25.
Okay. Solve that for sine C. Give me a number.
Okay. Let me see. So 21 sine.
No. Here's a case where you don't have to cross multiply, and in fact, it's self-defeating. So all you have to do is multiply both sides by 25. Notice? The reason you don't want to multiply the right side by 21, because then you're going to just have to divide by 21. So the answer is strictly 25 sine of 38 divided by 21. What's that number?
Well, let me look that right
now. The only time you want to cross multiply is if the variable you're solving for is in the denominator. Then you have to kind of cross multiply. But if it's in the numerator, you're spending 2 steps unnecessarily by cross multiplying.
Make sure all my parentheses are right. Okay, I got 0.732.
Now, that's equal to the sine of C. Now tell me what C is equal to.
Okay. Under sine. 47.054.
Okay. So that's one solution. 47. I'm going to just round off everything to whole numbers. I hate it that they do that. There's no reason to do that. There's no reason to force you in the misery of handling 3 decimal places. So anyway, it illustrates exactly the same principle by just using whole numbers and rounding off. All right. So the question you now have to ask yourself is, what's the other answer for C? This is one answer, 47.05 degrees. Well, remember that the sine is positive in the second quadrant. So the other answer for C is definitely 132.95. In other words, come up with both angles that work. If you take the sine of 132.95, you'll get 0.732. This is the first quadrant answer. That's the second quadrant answer.
Okay.
Okay. Now you have to ask yourself, is there room in that triangle for that angle? We know there's room for a 47-degree angle. Is there room for a 132-degree angle?
Maybe for B, but other than that, there is not.
No. There is for C. And the way you figure it out is you add it to the only known angle, which is that one right there.
Mm-hmm.
And if it doesn't exceed 180, then you can definitely draw this triangle that way.
Oh.
If it exceeds 180, well, then throw that second solution out, and you don't have the ambiguous case. Here's what we're looking at. There's your 25. There's your 38. Only in this second diagram, that angle is 132.95. This side is still 21. And what I'm pointing to there is not the 38. I'm pointing to this angle right there. In other words, angle C. There are the two triangles that fit everything you gave me. Those three variables apply to both of those triangles.
Okay, so then there's going to be two triangles.
Two different triangles. That's why it's called the ambiguous case of the law of sines. Because when we use the law of sines, sometimes we're going to have two triangles available. Sometimes we're only going to get a unique triangle. And it all depends on whether this second angle here can be included in this picture. In other words, you take this second angle, you add it to the only known angle, 38 degrees, not the 47 that we calculated, but the 38, and if it comes up to less than 180, it works. If it comes up to more than 180, you cross it out and go with the one triangle only.
Okay.
And it's a very special series of formulas that you have to look at to see. And the first book I looked at had a whole page on everything that had to be true for there to be a second triangle. And very confusing. I didn't want to memorize it. Nobody does. Whereas this method here is very straightforward. It's when you go to solve for angle C, that's what you're solving for, you actually get two answers. You get the first quadrant answer, and you got to examine the second quadrant answer.
Okay.
And if the second quadrant fits, then it's a legitimate answer. Notice the one thing that does happen is this angle A changes between these two triangles also. In other words, that is 85, so that's 95 in that triangle. But over here, it's 38 and 132, that's 170, that's like 10 degrees. So they're two completely different triangles, but both triangles have those parameters that apply.
Yeah.
That's
okay.
That's the ambiguous case of the law of sines. Now, shall we see if we got just about enough time to see if this other one is one or two triangles? No, we don't.
Well,
this is side, side, side. What do we have to solve for that?
Cosine, or law of cosine.
Law of cosines. The ambiguous case is only going to be if it's angle side side or side side angle.
Okay.
Never side angle side. That's never going to be the ambiguous case. It's got to be a triangle where you know theta, and you know this side, and you know this side. That's angle side side, or it could be this side and this side.
Hey, sorry, I don't mean to rush you, but do you think we could try and squeeze in one of the 6 questions real fast?
I don't know about squeezing. I have a 5:30 that I've got to go to.
Okay.
Which one of the 6? Yeah, I can do that, I think. Those don't look particularly difficult. In fact, we've done it already.
Yeah, the only difference is your sketch.
Oh, sketch a graph. Okay, that's real easy. Let's do one of those. Let's do that one right there.
Okay.
Okay. We figured out
what
it was. It was x squared over 9 plus y squared over 16 was equal to 1. Is that correct?
Yeah.
Okay. So that is an ellipse whose center is at the origin, it's a vertical ellipse because the parameter under the y is bigger. So it's an ellipse where it looks just like this. This dimension is 4 right there. This dimension is 3 right there. Now,
Okay.
Since we're sketching it, now that domain comes into play. When you sketch a parametric equation, there's an arrow on it.
Yeah.
And the question is how many times do you go around that circle as t goes from 0 to pi? And you sketch it clockwise. In other words,
Okay.
I'm guessing we go around it exactly once when you sketch a parametric equation. And in fact, if you do go around it twice, you don't see it. You just see it once. But what you remember, I do remember. Now, it doesn't necessarily draw the entire ellipse, but in this case, it will, because when you'll notice that x goes from 0 to 3, right? If t goes from 0 to pi, well, when t is 0, x is 0. But when t is pi over 2, then x is 3. So that's how you get that point. And y goes from 0 to 4, obviously. And as t is counting up, you're going to be going in this direction. In other words, as t progresses between 0 and pi, I'm almost certain you go around the whole circle at least once.
Okay.
I would have to kind of go through it to make sure that, in other words, you want to make sure that y goes from 4 to minus 4. Well, that's going to happen, I think. Yeah, because when t is pi, cosine of pi is minus 1. So y definitely is at some point there and is at another point there. And same thing with x. When x is, not sure x ever goes negative.
Well, sorry, Dave. I don't want to bring you over, so.
Okay, I'll let you go, Simon.
Okay, yeah.
And I will talk to you next time.
Okay, thanks.
You're welcome. Bye-bye.
Bye.